So the next thing that I'd like to discuss is temperature dependence of rate constants. Ibig sabihin, yung rate constants daw ay nagbabago depende sa temperature. So what is the relationship between the rate constant K and temperature? So that dependence is actually given by this expression. So we have K is equal to a certain pre-exponential factor, no? E raised to negative E sub A over RT. Now, this equation is what is known as the Arrhenius equation or Arrhenius law. Right? Ang ibig sabihin lang nito, the rate constant changes with temperature. If you increase the temperature, mag-i-increase din yung rate constant. Now, what are the variables and the parameters that are involved in these equations? So, yung A, which is our pre-exponential factor, this actually has something to do with the collision frequency. Di ba pag mayroon tayong reaction, nagkakaroon ng collision, if you further increase the temperature, this collision frequency will increase. Okay? And the reason why the reactants or the molecules will collide kasi syempre they have to exchange or rearrange themselves such that they will form the products. Okay, so that's your collision frequency. Yung E sub A naman, ito yung tinatawag nating activation energy. Okay, so ano tong activation energy? Activation energy is basically the energy required to form the reactants. Di ba? Meron kang, to form the products rather. No? So if you have the reactants, they need to rearrange them themselves to form the products. Maybe there should be some breaking and forming of bonds. So you have to have a certain energy level to achieve that, and that is what we call activation energy. Okay? R is the gas constant. And your T is, of course, temperature. And it should be in absolute units, which is Kelvin. Of course, K is the rate constant. Now, let's say you are given a set of data that contains different values of K and different temperatures. So how do we determine the parameters like the pre-exponential factor or the collision frequency and the activation energy of that particular reaction? So what we can do is linearize the Arrhenius equation. So if we take the ln or the log of both sides of the equation, ang mangyayari is magiging ganito. Ln of K equals magiging ln of A naman yung kabila minus okay, EA over RT. So ito na yung linearized form ng ating equation. So if we're going to make a plot of 1 over T versus ln of K, ang mangyayari dyan is that you will get a slope which will be equivalent to negative EA over R. And once we have determined that slope, we will be able to determine the activation energy. And ganun din naman yung sa ating y-intercept. So the y-intercept corresponds to ln of A. Now, from either of these two equations that we have right now, we can actually develop another equation that will give you or compare yung dalawang values ni reaction constant at dalawang temperature. So what am I talking about? So again, from these two equations, you can develop this third equation, and we will not derive it here, but this is basically algebra in order for us to get to this equation. So ln of K2 over K1, so again, there are two reaction constants, will be equal to EA over R times 1 over T1 minus 1 over T2. So as an example, let's say we have a reaction and we have determined the different specific rate constants at different temperatures. So as you can see, habang tumataas yung temperature natin, tumataas din yung rate constant. Okay. Now, what I would like us to calculate here is yung ating activation energy. So let me just write that one. So letter A, calculate the activation energy, and B, the collision frequency. Okay, so how do we do that? So, gagawin natin is, we have to plot 1 over T versus ln of K. So, kailan natin makuha yung 1 over T or the inverse of temperature. And you will be getting the following values. And also, kailangan natin bilang ating y-axis is the ln of K. So, let's go ahead and take the ln of the value of the rate constants. So there, and all we need to do now is make a plot of 1 over t versus ln of k, where 1 over t is in your x-axis and ln of k is in your y-axis. And here I already prepared the plot in Excel. So using Excel and using the plot that we obtained, well, we obtain here a linear graph and meron tayong na-obtain din na equation of the line, and the equation is right here, no? So yung y equals negative 11,703x plus 32.21, or we can rewrite it as ln of k is equal to negative 11703 1 over t, okay, plus 32.21. So as you can see, the slope in this plot is equal to minus 11,703. Okay, now this slope can be equated with the expression for our slope, and again, that's E over R. So actually it's negative. And we know the value of R, right? You can use the value of 8.314 joules per Kelvin mole so that we can get a value for the EA in terms of joules per mole. Alright? So therefore, masosolve natin yung EA or the activation energy. It's simply 11,703 times 8.314, and we will get 97,304.59 joules per mole. I'd like to convert this one to kilojoules per mole. So approximately 97.3 kilojoules per mole. So this is our activation energy. And for the collision frequency, in our plot, we obtain a value for the y-intercept na 32.21, right? Okay, so yung 32.21 na yan, let me write it here, next page, 32.21 is equal to ln of A. Alright, when we linearize our equation, our y-intercept is equal to ln of A. So therefore, A is equal to E raised to 32.21, and that will be equivalent to a value of 9.81 times 10 raised to 13. What should be the unit? Inverse minute. Kasi minutes yung ating rate constant according to our data in this problem. So this is now our collision frequency. Okay, so another problem type involving Arrhenius law is that if you have a value for a certain rate constant at a certain temperature, so what will be the value of that rate constant at another given temperature? Or vice versa. So for example, we have a reaction and yung activation energy ng reaction na to, so this is just an example. So we found that the activation energy is equivalent to 50 kilojoules per mole. Okay, so let's say that this reaction occurs naturally, no? So it occurs outside of the cell, okay, outside the organism, and it can also happen inside the cell or inside the organism. Now, yung activation energy na 50 kilojoules per mole, no? So, well, we don't have here a given rate constant, but what I would like us to calculate is what will be the change in the rate constant if, let's say, the reaction occurs at 25 degrees Celsius and we want to find the equivalent rate constant at 37 degrees Celsius, which is our body temperature, right? So, kumbaga, we are comparing ano yung for 25 degrees Celsius, ano yung for 37 degrees Celsius. So, if you have a value for the rate constant at 25 degrees Celsius, malalaman natin yung para kay 37 degrees Celsius. Pero since walang given, we can just compare, no? So, again, utilizing the equation we developed earlier or I've shown you earlier. So, yung ln of K2 over K1 equals EA over R times 1 over T1 minus 1 over T2. Alright? ln of K2 over K1 equals EA. Our EA is 50,000 joules per mole. Our R is 8.314. 1 over T1. So our first temperature is 25 degrees Celsius and that should be converted to Kelvin, which is 298 Kelvin. Then 1 over, so minus 1 over T2, which is 37 degrees Celsius, converting it to Kelvin, 310 siya. Okay, so here, you'll be able to obtain a value of K2 over K1, okay, utilizing our calculators, to be equal to 2.18 or K2 is 2.18. So approximately twice the value of K1. Ibig sabihin yan, yung K sa 25 degrees Celsius, 2.18 times that will be the K for 37 degrees Celsius.